All right, we're going to start a new kind of unit here, chapter. So chapter 5, starting with 5.1, trigonometric identities. I posted a kind of a document that has these identities up here. And an identity is just something that no matter what the angle, these always hold true. So the sine of 35 degrees equals 1 over the cosecant of 35 degrees. And the sine squared of 35 degrees plus the cosine squared of 35 degrees equals 1. So no matter what the angle, no matter what you plug in, so again, remember, angle A is going to be the same each time. So the sine squared of 3 pi over 4 plus the cosine squared of 3 pi over 4 equals 1 no matter what. And these are all derived. And we'll talk on the next video about how I can go from this sine squared plus cosine squared equals 1 to these other two. And we'll also talk about a couple other ones we'll add to it. But these are ones I said on there. You might want to print this off. If you need a copy, let me know. I can print one off for you. But the first thing we'll look at is these are all reciprocals. So notice how these are. These kind of go in pairs. So if you know sine, you can either just completely flip the fraction, because that's what a reciprocal is, no matter what. So if I ever have sine, I can flip it to find cosecant. If I have cosecant, I can flip that fraction to find sine. Remember, anytime you have just a number, you can always write that as over 1, so it turns into a fraction. So sine and cosecant are reciprocals. Cosine and secant are reciprocals, and of course tangent and cotangent are reciprocals. So those are super helpful. Sometimes you can use these quotient identities. Remember, quotient means division. So if I have both sine and cosine, I can divide them, simplify it, that gives me tangent, or vice versa. If I have cosine divided by sine, that's cotangent. So what we're going to look for is just giving a certain value. So hey, sine equals 2/3. What is something else? And these do get tricky. These are not easy. This is you can watch a video. That doesn't mean you can do it. You have to make sure that you try these problems, and you're going to get stuck. And if you get some help, you'll be fine. But they can be very difficult. As I said, I think for some people, if you like puzzles, this is your thing. If you like problem solving, this is your thing. But it can be very difficult. Okay, so here we go. So given sine of A equals 1/4, what is cosecant? The first thing we do is we say, is what I'm given and what I'm asked to find, are those reciprocals? Am I able to flip it and find the other one? And a lot of time the answer is no, and sometimes the answer is yes. So first, is sine and cosecant reciprocals? So let's look back up here at our pairs. I've got these two, and these two. So are sine and cosecant reciprocals? The answer is yes, because they're a pair of numbers right here. Well, that makes this way easier, because if I'm trying to find, in this case, if I'm trying to find, what cosecant is, then I know that the cosecant of an angle A is just going to be the reciprocal. So if I flip 1/4, that gives me 4/1. Or just, again, we obviously know that that would just simply be 4. Done. Now, are they always going to be that easy? Of course not. I told you this is going to be one of the difficult things that we do, so that's not always going to be the case. But look to see what it is. I've had people not realize that, and then they go all the hard work to find the exact same answer. Okay. Given cosine of x, and again, remember, and we'll talk about this, but all these values of a or x, we're never plugging numbers in for those right now for these values, so you'll never see that. This says cosine of x equals 3/7, find sine. So the first question, are cosine and sine, are they reciprocals? Well, no, they're not a pair of numbers. The next question we say, is there an equation, identity, that deals exactly with cosine and sine? So we'll kind of have to look back and go up here. Now, a lot of people want to say tangent, but that doesn't help us, because it gives us sine, or excuse me, in this case, it gives us cosine and says to find sine, but it doesn't give us tangent. That does help. Let's look down here. These Pythagorean identities, there's one that deals with sine and cosine. Yes, this one. Now notice this says sine squared plus cosine squared equals 1. It does not say sine plus cosine equals 1. That's a huge distinction. Sine plus cosine is absolutely not equal to 1. There's a reason these are squared. Now, people say, well, square root both sides. I can square root both sides, but you can't square root something that's being added together and simplifying that. That doesn't work like that. So I'm going to use that one here. So again, given this, I know that in this case, sine squared, I'm going to use x this time. It doesn't matter what your variable is, plus cosine equals 1. And I'm going to plug in what I know. Well, I know that cosine equals this, so this is going to go in here. And it's worth mentioning that if I say, what's the cosine squared, that's the same thing as taking your cosine of x and then squaring it. So when I go ahead and I simplify this, I'm going to say that the sine squared here plus I'm going to take this value and square it because it gives me what cosine is. So I'm replacing cosine of x like this. And this is now 3/7. So notice that I take that value, that fraction, and I square it. So then now I get cosine squared equals, when you square a number, not equals, when you square a number, you square the top and bottom. So 3 squared, that's 9, because that's 3 times 3. And 7 squared, that's 7 times 7, so that's 49. Now, we don't have sine squared by itself. Now, it wants sine, by the way, which we'll get into. So, to get this by itself, I'm going to have to go ahead and subtract. So, I have to get rid of this by subtracting. So, I subtract those two numbers. This cancels. So, now I have the sine squared of x equals. Now, 1 minus that. I don't have a common denominator. But I can multiply that top and bottom by 49 because we know that 49 over 49 is still exactly 1. Well, and I want that because now I have that common denominator. We have that denominator of 49, so we rewrite it that way. Then subtract 49 minus 9, that's 40. So what I currently have, I've got sine squared equals 40 over 49. And then to find what sine is, I'm going to square root both sides. So then that gives me sine equals, and don't forget, whenever you square root something, that's plus and minus. So then that gives me the square root of 40, and then the square root on the bottom of 49, which is just 7. And we can leave it like this. Technically speaking, you can simplify that 40. That's the same thing as 2 times the square root of 10, but we'll leave it like that. But again, notice that this can be a lot of work, and the first couple times you do this is not easy. This is why you really have to practice. All right, next one. Given cotangent of g equals 2/5, what is cosecant of g? So same thing, are cotangent and cosecant reciprocals? Well, no, because here's cotangent and here's cosecant. That doesn't help. Okay, these don't help me either. Is there a Pythagorean identity that deals exactly with cotangent and cosecant? Yep, I got it down here. I've got 1 plus cotangent squared equals cosecant squared. Well, that's good. I'm going to use. So I'm going to use 1 plus cotangent squared, in this case of g, equals cosecant squared. And then I'm going to plug in this. I know that cotangent of g equals 2/5, so I'm going to plug that in. So then I get 1 plus cotangent, that's 2/5. And remember, we're squaring that. And then that equals cosecant squared. So when I square this number, 4 squared, or 2 squared is 4, and then 5 squared is 25. And remember, I have a 1 in front. So how can I rewrite 1 so it has the same denominator as 25? Well, we know that that's simply just 25 over 25. And I can work with that. And so then that gives me cosecant squared. So then add them up. Well, my common denominator is 25. If I add those together, I get 29. And so then that gives me cosecant squared of g. But again, it asked for cosecant, not cosecant squared. Well, we know that to get rid of something being squared, we'll just square root it. So then this will give me what I need. So then cosecant of g. So plus and minus. The square root of 29, that's not a perfect square, so we'll leave it like this. The square root of 25 is 5. So then this is my answer. So these are how you start these problems, and they certainly get more complicated. So you have to get the somewhat easier. I don't think these are easy, but you have to get some of the easier, more basic of these problems first before you can get some of the harder ones.